Welcome to Storytelling with Data, the podcast where listeners around the world learn to be better storytellers and presenters with best-selling author, speaker, and workshop guru Cole Nussbaumer-Knaflic. We'll cover a wide range of topics that will help you effectively show and tell your data stories. So get ready to separate yourself from the mess of 3D exploding pie charts and deliver knockout presentations. And with that, here's Cole.
Hi, this is Cole. Thanks for tuning in today. So my second grader, Avery, came home with a math test recently. I found it in his daily folder. It had been graded by his teacher. So I'm flipping through it, feeling like a proud parent. Early signs are that math is one of his strong suits. I arrive at a bar graph that he has drawn. And now I'm feeling exceptionally good about things, right? He's 8, and he's already graphing data. But then I notice that points have been deducted. So I'm doing the math, checking the bars, and they are correct. I'm starting to get a little worked up, but then I read the directions. It turns out he wasn't meant to draw a bar graph. He was instructed to draw X's in a stack to represent the data. I've got mixed feelings about this. On the one hand, I love that it was intuitive to him to draw a bar chart and that the one he drew was correct given the data he was plotting. Sort of amazing because I don't think he's encountered that many bar charts in his life. Maybe more than the typical second grader given my profession, but still, this does seem to reinforce the efficacy of the bar chart as an intuitive way to show data. But then, of course, there's the whole following direction part. I suppose that's important too. Stepping back from this, I realize we all do this. We don't always read all of the details. We make assumptions about the graphs we see. So it's possible, probable actually, that we misinterpret some portion of the graphs we encounter. That misinterpretation can be driven, or maybe it's better to flip that around. The clarity can be hindered when the data visualization is created and also when it is consumed. So I thought it would be good to chat about misleading graphs from both of these perspectives. Rather than simply listen to me drone on about it, I invited my friend Ben Jones to join me for a conversation about misleading graphs. That conversation is what you'll hear next. Hello, and thank you for tuning in. I'm Cole, founder of Storytelling with Data, and I'm here with Ben Jones, founder of Data Literacy. And we are going to chat today about misleading graphs. Intentionally misleading, accidentally misleading. It's helpful to understand in either case what that can look like. Because when we do so, it means we can be aware and cautious, both as the consumers of graphs and other data visualizations, but then also, of course, when we're creating graphs and the broader communications in which they sit. So I'd like to kick things off by asking those listening to think about a couple of things. First off, what is a way that you have witnessed a graph mislead? See if you can get a specific example in your head. And now, so we don't just end up focusing on the dark side of things, I'm curious, how did you know or learn that the graph was misleading? What were the clues? And if we think about moving beyond simple criticism and into the realm of constructive, how can we learn from this, both as we're consuming data visualizations and also as we're creating them, so we aren't inadvertently misinformed or misinforming? So Ben, I thought you and I could start by sharing some of the ways we've seen graphs mislead and what we can learn from those instances.
I would say every week there's something that's going to come across your radar that's going to make you either puzzled or get your radar of let's say BS going. And so the problem though is, like you said, sometimes it doesn't happen and sometimes you don't get that radar going. And so now maybe you feel like you've learned something, but actually that's wrong. You've actually acquired some false knowledge, if there's such a thing. So It's not always obvious to us what's wrong with the chart, and maybe we're not even aware that there's anything wrong with the chart. And those are some of those problems that maybe we might not even be aware of in a given moment.
And that's the difficult part of this, right? I used to have a boss who called it your data spidey sense. So sometimes there are obvious things that set off that sense, but other times we may be consuming something and not even realize it because we're so used to seeing something a certain way, or we're making assumptions about what we're looking at that may not be entirely accurate. So is there an
Yeah.
instance that's top of mind for you?
Yeah. Yeah, just like you're describing, we're kind of just diving into a chart and everything's great and we're looking at it. I had an experience like that not too long ago. So it was actually while I was writing a book called Learning to See Data. I have three sons. One just graduated, one's about to graduate. And so the topic of graduation rates was on my mind for one reason or another. And so I looked up the topic online and came across a report by the NCES, that is the National Council of Education Statistics, I think. It's a US department. So I was just taking a look at it. It was essentially just, in fact, if anybody's interested, you can just go to bit.ly/badviz. It's the third slide down. The first chart you see in that Google slide presentation, and the third slide is the chart that I'm referring to right now that I came across. So if you're not at a computer, no worries. Imagine a map of the United States. It's a state map. So every state is shown, including Alaska and Hawaii. And then basically it just shows the graduation rates by state. And so I was just taking a look. I live in Washington. I'm up in the top left corner up here. And I thought to myself, oh, how interesting. I didn't know that, Oregon had a higher graduation rate than Washington. I just wasn't aware of that. That was initially what I saw. And so, well, then I looked a little closer and I realized the labels told me otherwise. And so I tried to figure out, why it was that I initially took away something incorrect from the view. And then as I looked at the legend, I noticed that what they had done, and I don't mean to disparage the people that made this chart. I mean, maybe it was a software default. Maybe they had a boss overruling them and telling them they had to do it. I mean, who knows, right? But the fact of the matter is the legend in the chart, it's a green map where each state is a certain shade of green. And for some reason, it goes from a darker shade of green if it's in the 70 to 80% graduation rate to a lighter shade of green if it's 80 to 90. And then when it gets to 90 plus, it gets to actually the darkest of the three. So in other words, the color scheme is sort of out of order, right? So Washington is a lighter shade of green, even though it has higher graduation rate. So it's really, I talk about this in that book, Learning to See Data. It's a violation of what we in the Viz field call the expressiveness principle, right? Where there's a choice made in the encoding that gives you the false impression about the order of the variables in the data. So it's sort of expressing something that's not in the data, which is a problem, right? Because your first reaction is going to be to assume that a darker shade is associated with a higher graduation rate. And so getting it out of order like that, I think, was the reason for it. But to your point, I mean, I didn't even really notice it. And maybe I wouldn't. I had to look closer. Maybe I'm just lucky that I happened to dive in and look closer. Who knows, right? I guess the question is, how many times did I have a similar experience, maybe, but not realize,
it.
right?
Yeah.
And so that's a question, right? So it reminds me of this quote from Mary Eleanor Spear. She says, "Learn to see details. There's quite a difference between simply looking at a chart and seeing it. Looking is your first visual impression, while seeing involves the studying of distinct parts of the visual." And that's really, I think, where I realized, hey, I need to be a little more thorough
Yep.
about looking into some of these details. So
Well,
that's
and
an
that's
example.
where, right,
Yeah.
reading titles, reading legends, making sure that things make sense within that, I think, as you're consuming the graphs, but then as we're creating them, really stepping back and thinking about what are people's expectations likely to be when they look at this? And how can I
Mm-hmm.
work within those expectations so that I reduce the possibility that someone's going to misread it by looking at it with a cursory glance and not, seeing it, to your point.
Right. Yeah. And even just asking other people, hey, what do you see?
Yep.
What pops out at you? That's a good way we can avoid misleading others, is just by trying to find out what sorts of interesting things do they notice, or maybe what do they not notice that we would hope that they would. So those are some good techniques. And then just to watch ourselves too as we observe these charts and take them in, kind of become more aware of what are some of the things we are maybe lazy about, or some of the shortcuts we might be taking that might be getting us into trouble.
I love the tip of having someone else look at it and tell you what they see, because I think too often we skip that step because we think it's obvious, but it is. It's obvious to us because we're the ones who created the graph. And so we've got all this tacit knowledge and these built-in assumptions that someone else won't hold in the same way. So getting input and a fresh set of eyes on your work, it can always be an enlightening, and you get input that helps you be able to refine and do smart things that will help you from creating things that are misleading.
Yeah, and that's really what, Enrico Bartini, he teaches data visualization at NYU. We had a chat on Twitter about this exact topic of expressiveness a while ago. And he really opened my mind to that, the fact that expressiveness is more than just, did you get the order right of the colors? I mean, that's an example of it, but there's so many other things. Like many times you'll talk to someone and they're going to assume that if a value goes up or a line goes up, that that's more or better, that it indicates that idea, right? Maybe it doesn't. So maybe it actually is the opposite, where if a line goes down.
Yeah.
Yeah.
A couple examples come to mind of this, of things that I've seen recently. And it's another one of these, violations of expressiveness, but which is when time isn't ordered in a meaningful way or is sorted differently than we expected, right? So it turns out some tools make it really easy to accidentally sort a value by date, which if you're not careful means you could tell a story about a trend that isn't even there, right? I saw a recent example. I don't even recall what the metric was that was being plotted, but it was a line for men and a line for women. And both lines started out at the left-hand side of the graph. And they started out near the same point. And then you could see the line for men was going up and the line for women was going down. So this gap was forming visually. But when you looked closer, the dates ran backwards on the time axis.
Oh, yeah.
So really, the things were getting closer together, not farther apart, but you had to stare at it for a while and really look at the details to be able to see that, which is a problem.
Actually, that exact one you're talking about is, for those of you who popped up that slide presentation I gave at the beginning, which if you just joined, it's at bit.ly/badviz. That's on slide number 7. And, it does look like they're converging, but actually, you're right. One of them is flipped, where the time goes from right to left. And actually, there's a great book out there called Mind in Motion by Barbara Tversky, who's a researcher. And she talks about all of her research that she did in this area, and specifically with regard to change over time, which direction is time going, increasing or progressing forward. So she did this research, and here's how this research went. I find it fascinating. It's kind of fun to think about. So they took a bunch of kids, school-age kids. Some were American, some were Israeli, some were Arab. And they gave them a blank sheet of white paper, and with 3 dots. And they put 1 dot in the middle of the paper, and they put the word lunch on it. And then they gave them 2 other dots, and they said, okay, put these dots where you think breakfast and dinner goes. 1 dot's for breakfast, 1 dot's for dinner. Where should they go? And so there's a huge correlation between where they put those dots. And if you're listening, imagine, where would you put the dots? Most of us probably would say, oh, I'd put the breakfast dot to the left, and I put the dinner dot to the right, maybe. And so what they found, though, is it's really seems to be somewhat correlated to the direction of language, written language. So if you learn to write left to right, like in English language or Spanish or many other Latin languages that go left to right, then that was a pretty high percentage would go in that order. The children who were learning school in Arab countries would do the opposite. They would go from right to left because Arabic is written right to left. Well, Hebrew was a really fascinating example because the Hebrew written language goes right to left like Arabic. But unlike the Arabic children, they learn numbers left to right. So the kids going to school, as I understand it from her book, are going to learn to write words from right to left, but numbers from left to right. And they were about 50-50. So that was an interesting finding, that there does seem to be that. So, but that gets back to what you're saying, right? Is that your convention or what your chart is expressing is dependent on that audience somewhat.
Yes.
And it could be culturally dependent. It could be dependent on a number of factors, right? You may not know what a person is assuming when they come to look at what you've created.
But this is another great tip, right? Going back to this idea of getting somebody else's eyes and input on it. If you know you are communicating to an audience who is different than you, who has different conventions or constructs that they're working within, try to find someone who is representative of that audience and have the exchange with them, right? Because then you get a glimpse at what that might look like.
Yeah, and it forces you outside of your comfort zone. You can't just talk to the same people every time. can't just talk to people like you every time. You've got to go beyond that and try to figure out other people's perspectives, especially if your audience is broad. That's an important piece of it. What was interesting too, though, is while the left to right seemed to be time conventions seem to be culturally dependent, what she also discovered, and in her research, she shows the fact that the high-low convention isn't actually culturally dependent. And so her assumption is that a broader percentage of people, like people from all over the world, have this assumption that up is more or better. And she thinks because gravity is the same for all of us, right? It pulls us down. If you're going to climb a mountain, that's going to require a lot of energy and power, perhaps, and it's a good accomplishment. So yeah, that idea of reaching new heights is actually not seemingly tied to cultures as far as people's conventions, because we've seen people flip the y-axis. I think there's a famous one that shows gun deaths, I think it is. So it's a tough topic, unfortunately, that we cover often in this country. But yeah, I think it's a famous example where they flip the y-axis so that, yeah, it's actually, if you're on my slides, it's slide 53,
Is
gun
this
deaths
so that
in
it
Florida.
looks like blood going down? Am I thinking of the right
Yeah,
one? Yeah.
exactly.
Yeah.
They shaded it red and they flipped it, and then it's by Reuters. And then it looks like gun deaths are going down recently, but it's actually because the low numbers are at the top and the high numbers are at the bottom. So the line's going from less to more, but it's doing so by going down.
Yeah.
So that's an example where it probably breaks the convention that most would assume.
Well, and I just want to be clear, this doesn't mean you can't ever break the convention. It means when you do so, you want to make sure it's intentional and that you're
Right.
doing other things to make that clear, right? And that's where clear titling and labeling or calling out a specific data point and describing how to interpret it or highlighting a takeaway, all of these things can help lend understanding when it comes to somebody else subsequently interpreting the information.
Yeah, I mean, I couldn't agree more with that point, Cole. People will take some of these examples we're talking about and from that infer some ironclad rule that's written in stone. Oh, you never turn the y-axis upside down. Well, what about ranks? I mean, if something's ranked number 1, it's higher or better than something that's ranked number 10 or 100. So that's a mistake that I think people make, is by taking these examples and saying, oh, I'm never going to do that again ever. But there are plenty of cases where you would go outside of quote unquote best practices, which is a term I tend to try not to use. But yeah, there's lots of cases where you'd want to do exactly what someone shouldn't have done in a different scenario, in a different case, right? And with a different data set.
All right. So we talked about some examples that show, that are going against people's conventions or expectations and how that can be dangerous, right? So we want to be aware of when we're doing it. So getting fresh eyes on our work can help with that. And also clear titling and labeling can help. I want to bring up another category, if you will, of ways in which graphs mislead. And that is when the area is somehow misused, right? So an obvious one that we see many of, or too many of, I should say, in the media, pies that sum to more than 100%, for example. And I know you have some of those in your repository as well.
Yeah.
But I think a more nuanced one that isn't always as obvious is bubble graphs. So I am always skeptical of bubble graphs because I've just seen too many, one, there's just a lot of stuff going on. It's a lot to try to interpret. But I think worse than that is I've seen too many where the bubbles themselves aren't sized correctly, right? And so the way to correctly size is by relative area. And it's actually poking around, and Robert Kosara has a great post. It's from 2008, but algebra doesn't change over time, so it's still totally relevant, it's called linear versus quadratic change. And he just goes through simple terms of how we should scale things visually when we're doing so by area, so that we don't inadvertently make it really easy for people to make a false comparison.
Yeah, it's reasons why some newer software platforms default to that. They put anything you put on an area control has surface area, or as opposed to some linear kind of an example. Because yeah, I mean, if you take something and you make it its diameter, circle its diameter twice as big, you'll say, well, I'll make the diameter of the circle proportional to the value in my table. Yeah, it's not going to work, right? Because the area of that circle doesn't proportionately increase. And that happens a lot. In fact, there's examples of some experts going back over 100 years who point that out. People like Willard Cope Brinton, who wrote a book called Graphical Methods, I think, for presenting information. Something along those lines is the title of his book. Brinton is his name. And he talks about that with relationship to icons. So if you make a person twice as tall as another person, well, they also have twice the shoulder width, and therefore the size of that person and the perceived weight of that person or their volume would be quite a bit more than if you just use two bars of the same width and doubled the height or doubled the length. So yeah, that's a common one. It's just not getting those proportions right. And that can be very misleading.
Well, and that reminds me of another one that I saw that I think I saw in your repository that I've seen elsewhere as well, which was average female height. And it shows heights by different countries, but the scale on the y-axis goes from 5 foot to 5'7". And so visually, right, they're encoding by length, but they're not showing the whole scale. So visually, it looks like the average height of a Latvian woman is like 4 times the average height of an Indian woman.
Women in Latvia evidently are gigantic. Yeah, it's a kind of a double whammy. I mean, they cut off the y-axis, which I guess we can get into that conversation too, right? So they do that. They truncate the y-axis, but then they also use the size of icons mapping to the heights. Yeah. So yeah, it's definitely doubly misleading and in a kind of a comical way, maybe.
Well, and so maybe that's a good segue into non-zero baselines. the classic that I've seen on rotation recently, I think as a result of some of the tax conversations that are going on with capital gains and all of that sort of stuff, but is one from the Fox News that was, I think it was originally published back in like the fall of 2012. So like several presidential election cycles ago. But we're standing in 2012 and it was looking forward to 2013 and trying to answer the question, what happens if the Bush tax cuts expire? And so on the left-hand side, you had the top tax rate today at 35%. On the right-hand side, the top tax rate as of January 1st, 39.6%. But then over on the right, there were some tiny numbers for the y-axis, and they started at 34, which meant when you looked at the heights that were being plotted, right, 35 minus 34 on the left is 1, and then 39.6 minus 34 on the right. So the visual increase was 460% versus an actual increase, if you do some math, of I think it was something like 13%. And so I think you mentioned before there aren't really rules, but this is one, and I'll be curious on your thoughts here. This one feels like a rule to me, which would go, if you are encoding a variable by height, you need to show, or height or length, you need to show that entire quantity to allow the person who's looking at it to make accurate comparisons. Because when we chop off those bars, right, whether it's women and average female height or top tax rates or anything else, we're invalidating the visual comparison. I don't know. What do you think, Ben? Is that a hard and fast rule, or are there exceptions?
It's pretty close. It's pretty close because, again, like you're saying, you're trying to show the length of something and give people this idea that something is, proportionally larger or smaller than something else. And so, yeah, if you just arbitrarily pick where you start the shape, probably a rectangle, then they're drawing conclusions about the relative size and it's going to be all wrong. And I think that is super, super applicable, like 98+% of the time. I mean, we can think of some examples. Like there are different quantities. Some of them are what we call ratio quantities, like let's say weight or height. So for those types of quantities, 0 means nothing, right? 0 means absolute lack of that thing. If something weighs 0 pounds, then there's nothing there. But that's a little different than other quantities, like let's say temperature is kind of the classic example people use, where 0 degrees Fahrenheit doesn't mean no temperature or no heat. And so you can imagine how maybe someone wants to show the relative temperature in the room. And maybe we're talking here about a very specific manufacturing process that's really, really finicky. So to say, oh, you have to put your bar chart at 0 degrees Fahrenheit when your yield is 100% if it's at 80 degrees Fahrenheit, and then the yield drops to 10% if it's like 82. So I would say, oh, there's a scenario, right, where you're probably going to want to show comparisons using, and probably you can just default to lines in that case. So you may not even.
That'd be one way to avoid it altogether.
Yeah.
Right. But I get what you're saying.
Right.
If you could have, if there's a natural point that you use as your baseline that then you could show deviation from that. But then you're sort of,
right.
it's not exactly we could argue.
There are some cases, but again, I think that, yeah. But here's another example, right? So, here's what I think people. So here's what they say. Oh, I heard your y-axis has to start at 0, and so they say, oh, well, all of my y-axes from here on out are going to start at 0. Well, not if the value goes negative. I mean, we might be talking about distance above or below sea level.
Yep.
Well, it isn't height anymore. It's now relative to a 0 point, which is sort of the surface of the earth, where you could be in a place like the Dead Sea where you're below sea level. So that's a negative value. So of course that y-axis is not going to start at 0. It's going to go to a negative value. It might include 0, right? And that's, I think, maybe the more general rule isn't that it should start at 0, but that maybe most often it should include a 0 point. And I would say with the caveat that maybe 0 doesn't mean much for a particular variable. And in that case, I probably wouldn't worry about it.
Ben, other examples that you've seen lately?
I gotta say, I mean, this one is a tough one. So last year, obviously COVID, right? So, I mean, never in the history of the human species has this many people been looking this closely at basically a data set or visualizations about the exact same phenomenon. And so that's a really remarkable thing that happened last year in the world of data viz. And so prior to that, I don't think I would have imagined showing a really broad audience a logarithmic scale axis. I don't know if I would have done that. I mean, I went to engineering school, so I got used to them, but I'm also aware of the fact that a pretty large percentage of people really kind of struggle to read and understand those.
We do.
So there was actually some
banking.
Yeah, go ahead.
In banking, depending on where you're at, they can be more pervasive for showing credit risk, right? The doubling
Rates.
of odds. Yeah, it's sort of the perfect thing for that. But yeah, I agree. Outside of the perfect use case, logarithmic scales can get pretty murky pretty quickly.
Yeah, and I mean, with the disease spreading, I mean, that is a perfect use case because it's an exponential phenomenon. So you're going to want to show that, or at least it could be very useful or interesting to show it in that way. And so there was actually some research that was done into that. And for example, they showed a version of the same chart using a linear y-axis where you can see the line really taking off exponentially. And they asked people questions about it in fairly high percentage. I think the number was 80% or thereabouts got the questions correct. Then they showed another group, same data, but using a log scale chart, where instead of an exponential curve, there was a straight line because that's what happens when you plot an exponential function on a log scale. And only 40% got it right. So I struggle with that a little bit because if you say, oh, well then, hey, that's a misleading chart, don't use it, maybe, but also what if it is a better way to show the data? I think in those cases, well, I'm curious to hear what you think, Cole. What do you think would be a way to work with that sort of a situation?
Yeah, I share your concern at the idea of, no, we shouldn't use it because people are misinterpreting it. I think for me, that sounds like opportunity, right? Because when it is a good use case for something like that, we shouldn't shy away from it. Rather, we should use it as an opportunity to teach people how to read it and improve the graphicacy or graphical literacy of people broadly. And so with logarithmic scales, one thing that I've seen, and we used to use this when I worked in credit risk management in banking, would be show people a specific example that you're pulling out of the data, right? So you show the curve or the line, but then you take a specific point and you say, here is how I interpret this, right? So with credit risk, here's someone who has a credit score of 780 versus someone who has a credit score of 800, right? Here's where they are on the graph. And now you might think to yourself, well, they're not much difference, when really the person who has the 780 credit score is twice as likely to default and not make their payments versus the person with 800. So you can use real things that people can get their head around and then show them where it's at in the graph as a way to help people understand how to read the graph. And particularly if it's something that you're going to be communicating on a regular basis, taking the time to do that and make your graph intelligible so that people can understand it and interpret it correctly, and you can speed up that process as you use it more over time. I think there's great utility in doing that. And we should not shy away from doing things because people are going to, I don't know, I feel like as the designers of information, we need to know when to to push and when to use opportunities like this to help broaden the sorts of graphs that we can use. I think it was RJ Andrews who I was chatting with recently who made the point that like bar charts used to be a new novel thing, right? There was some point in history where people had to learn
Exactly.
how to read a bar chart. And like now it
Right.
seems like common sense, or I don't know, you and I see so many bar charts but then that's a double-edged sword because we see so many bar charts that you have certain expectations that go along with that. And when those expectations aren't met and you're not taking the time to look at the details, like that's when we can get into scary spaces. Because I think the misinterpreting graphs happens probably most frequently at both ends of the tail, right? For people who aren't looking at data very often and for people who are looking at data all the time. Whereas probably people in the middle there are spending more time reading and looking at the details and questioning things maybe in ways that is useful.
Yeah, I think you're right. We shouldn't just shy away. Oh, people aren't going to get it, so therefore that's a no-go. We just can't even think about it. I don't think that that's a good approach either. But I think it is important, like you're saying, to go in with your eyes open. Okay, this is going to be misleading or confusing. What are we going to do to head that off at the pass and turn it into a teaching moment? And I actually think this is one place where animation can be useful. I mean, a lot of times we think about animation as being this whiz-bangy PowerPoint thing where stuff flies in from the left to the right or what have you. And it's just really, I would say, just gratuitous and in most cases, really annoying animation. But with a chart, you can actually show people something and teach them something. Let's say, for example, if you started off with a linear scale and said, notice how this is an exponentially increasing series, and then say, let's change the scale and actually have, instead of just taking it away and then showing them a brand new one, actually have the software animate that. And some software packages nowadays are making that easier than ever.
Yep.
So it would actually show me the change sort of unfold as the scale changes. I think that that kind of technique might be a helpful introduction or bridge, if you will, from an audience that is going to be confused to try to get them to the place where they have that aha moment and not just kind of back away because they don't get it. So I don't know. That's one thing maybe.
Yeah, I think that's a super elegant solution for that sort of scenario, right? And it's not the bouncing, flying, throbbing sort of animation. It's motion for a purpose. And so when that purpose is to orient people in something they know and use that as a way to connect them to something new in a way that now the new thing doesn't feel as intimidating because there's something known about it, that can be a really nice way to communicate to people.
Yeah, and when they're I like what Our World in Data does with this. Ourworldindata.org. They've been working so hard the last year and a half to compile all this data for us, and governments around the world, it's amazing, are using the charts and the data they're compiling to make decisions. It's a really remarkable thing that I think has transpired in lieu of, or I guess absent any kind of global official record keeper for this kind of public health data. But what they do is they just give you an affordance. So this is helpful for scenarios when people can interact with the data that lets you toggle between linear and log. So we're kind of maybe beating the linear to log example to death a little bit, but letting people see the switch, right? So, okay, I can see what it looks like when it's linear. And then, wow, I can actually see that looks very different now. And I can actually look at it in both ways so that if one way is likely to be confusing, then maybe there's a way to let them make that comparison and kind of go back and forth to avoid the misleading nature of just showing them one or the other. I mean, we don't always have the opportunity to give interactivity, right? And maybe that's just something you can demo if you're in a live presentation.
I like how you framed that because when we do it in something static or something we're sending around, it needs to be in the words that are there with what we're sending. And if we have the benefit of presenting live, then we get to do that with our voice, right? And in coordination with the words that are there. And so that can help us take something. And I think we talk about this idea of using something less common or that might be more easily misinterpreted, that when you have the benefit of being with your audience and being able to talk them through it, right? That's going to be oftentimes a more successful scenario to try to do something like that versus something that you're sending out or that's being published in a static way and you're not there to have that flexibility.
Yeah, what makes a chart misleading is sometimes highly dependent, right, on how it's shown.
Yes.
What's the medium? What's the channel? And also ways you can work around that are also dependent on the same thing. Are you there to talk about it? Do you have to create some sort of experience without the ability to talk people through what they're seeing? And is it static? Is it interactive? Is it on a phone? Are they at a computer? All those questions, I think, relate to this exact question. What are the likelihood, what are the odds I mislead someone with a chart that I make?
And the more we think about all of those sorts of aspects of the communication, the more we can try to optimize things, right? So that we're doing good with data and not misleading inadvertently. All right, so we've talked about going against people's conventions. We've talked about some area issues, quite a bit of time on logarithmic scales, right? And I like the general theme of what we've been talking about, which is one of the themes, I guess, is that there aren't hard and fast rules with most of this stuff, right? There are guidelines and conventions, and it doesn't mean we can't go against those things, but it means that we need to be thoughtful when we do so and take care in labeling and titling and explaining. I think one of the things that's come up several times, but we haven't maybe emphasized when it comes to another category of ways in which graphs can mislead is just when they overcomplicate things, right? They're unnecessarily confusing or somehow easy to misinterpret. And this is another one of those categories that can take a lot of different forms, right? So it could be that the graphical form or the way that we're encoding the data doesn't make sense for what's being plotted. Or I see a lot of instances in the business world where the title and what the graph shows don't match up or don't go together. And so they both end up confusing each other as a result of that. Or there was one recently actually with a client where, and I see this not infrequently, which is where the data labels are showing something different than what is being plotted. So in the example I'm thinking of, they were plotting the percent of total in stacked bars, but then the labels on the bars were the absolute numbers. But the categories that were being plotted in the stacked bars varied wildly in size. And so there was one segment within a bar that was labeled 400 that looked way bigger than another segment in another bar right next to it that was labeled 1.6 million. And so when you see things like that just don't add up, it calls everything into question, which is something we want to be careful about. And I think this is another instance where getting someone who is less familiar and having them look at your work and provide feedback can be super useful.
Yeah, and just to pick up on that, this idea that, well, are we showing something? I mean, maybe we're showing it in the right way, but what we're showing is actually highly complicated, or maybe like the Rube Goldberg machine, maybe more complicated than it needs to be. An example of that, so Enrico Bertini, I mentioned his name before, he's been calling out some things like this, and I know he's interested in this from a research point of view, and we had a chat about it. And so he talked about a chart, and before I even say what it is, I mean, I need to stop to acknowledge the fact that we're talking about death, right? So, I mean, to me, one mistake people often make is that they don't stop to acknowledge that that's people's family members, right? So that's what the chart is about that he's referring to in the New York Times. And really all it's showing is it's a bar chart that shows the difference in the death rate per year as compared to what was expected. And so obviously last year was much, much, much higher than really any other year in the data set, even higher than the 1918 flu, but it's a percent difference. So if you take the amount of deaths that were expected based on a linear trend of the last 5 years, and then you say, okay, how many did the country actually see, regardless of what cause it was for? And then you say, what was the percent difference between those two numbers, what we actually saw versus what we expected? So that's already a very complex thing that's happening. I mean, mathematically it isn't complex, but it's a few conceptual steps, right? There's more than one calculation happening there. And I think his point is that, well, that's a fairly complex place to start, which is the place where the author started in the tweet thread. Later on, there's one that just shows the change and the expectation and the actual. And so I think his point was that would have been a better place to start because it doesn't require so many mental wrestling steps to get to the place where you understand what it is that chart's telling you. Does that make sense? So not that the chart's wrong, it's just that maybe that was more confusing than you could have done for step one.
Yeah, and I think the challenge when we inadvertently make things more complicated than they need to be is we miss out on communicating to a lot of people because either they've maybe misinterpreted something and come away with a false conclusion, right? Or they don't have the patience to do the mental acrobatics to figure out how to read it. And so, yeah, I think when we can simplify, right? And it's not about oversimplifying, just not making things more complicated than they need to be, and getting other people's eyes and brainstorming and talking through things with others can be a great way to illuminate new paths that you may not have thought of, right? Because a lot of times we'll be doing something complicated behind the scenes to analyze our data or find the interesting thing, but there can be value then in stepping back and rethinking how we then subsequently show that to communicate to somebody else.
Yeah, I think that's it, right? Because when you've been working with the data for as long as you have, that fourth or fifth or sixth step isn't that tough for you. But then
Right.
it's important to remember, oh, I'm showing this to someone who's still at step one.
Exactly.
And so maybe I don't need to have them make such a big leap to begin. Maybe I can step them to a place where eventually, yeah, I would argue, that's a perfectly valid chart to show them. Maybe it's a place where we arrive as opposed to a place where we start. And so then I think sometimes the misleading nature of a chart might actually be the order that it's shown in a presentation.
Oh, that's
Um,
interesting.
yeah, it isn't necessarily whether it itself is fundamentally broken or misleading in a way that is irrecoverable. It's just that, well, you got the order out of you showed it out of order.
I think this is a good point to take a short break.
Are you looking to bring your data to life and use it to communicate a compelling story? Would you like to learn the fundamentals of effective visualization and data storytelling directly from Cole and the Storytelling with Data team? Then consider joining us May 19th, September 22nd, or October 19th, 2021 for one of our virtual 5-hour workshops. These hugely popular sessions fill up fast and sell out quickly, and after June 1st, they will also be increasing in price. So lock in your lower price today, and as an added bonus for our podcast listeners, you can get an additional 10% off with the promotion code PODCAST10 entered at checkout. That's PODCAST10 for an additional 10% off our legacy pricing. There's never been a better time to improve your data storytelling skills. Visit storytellingwithdata.com/workshops to register. That's storytellingwithdata.com/workshops and register today.
I have a question for you. This one might be a little bit. It's hot off the presses, so it's from 2 hours ago. So Greta Thunberg tweeted about who emits the most carbon dioxide emissions by global income groups. And it's a few years old because I guess that's when the data is most available. But basically, it shows that the top 1% of earners in the world emit average per capita carbon emissions in tons is over 70. And then if you go down to the bottom 50% earner, that number is probably something like less than 1, right? So it goes from 70 down to 1. So her comment that she makes is that, hey, we can't solve this climate crisis without addressing what she calls the elephant in the room. So she's showing just the per capita rates of these different individuals in the world. By I mean, I think it's so yeah, I'll stop there. I just want to hear.
So this brings up another sort of category that I had in mind that we haven't talked about yet, right? Because the things that we've talked about so far, the ways that graphs mislead, are all things that you can see, but we can mislead through all the things that you can't see, right? The data hasn't been collected or analyzed properly, or it's been cherry picked, which in this situation, maybe there's a bit of that, or right, you're not showing maybe the full picture, or it's from an unreliable source, right? You used a phrase that stuck with me. I think it was in Avoiding Data Pitfalls, which was this idea of interrogating the data. And so, I mean, this is me trying not to directly answer that question because I don't really want to, but you can't just, I don't know. It's hard. I shouldn't say you can't, but if you're just picking two numbers, right? Or you're just showing the rate, and anytime you're just showing the rate, there are absolute numbers that go along with that actually are going to tell a big chunk of the story a lot of the time, right? So I don't have the graph, I haven't seen it, but the size of the different groups that you talk about is obviously very different. And so when you take those things together, maybe it's still the same conclusion, but why would we want to open ourselves up to attack for telling a one-sided story if that's the case? And so the absence of information that feels relevant, I guess, would be the thing that we can maybe see in those instances. I don't know. You go through so many lessons in avoiding data pitfalls. I'm wondering if there's any that you want to highlight that are particularly relevant to our conversation here when it comes to some of the things behind the scenes.
Yeah, well, first of all, I will say I agree with you 100% that the issue there, if there is one, isn't in the specific chart that she shows or the point she's trying to make. Is that it's only showing one side of it. And again, not that it's invalid, it's just that let's consider it in a few different angles. It isn't just about the per capita, it's also about how much total emissions do you have for each of those groups, like you said, the absolute amounts. And so then you're opening yourself up to being accused of telling a one-sided story, which is how you put it. And I think that that's perfectly eloquent. That's exactly what the issue is there. And people do that a lot, right? They're going to show the side or the story or the angle that is most aligned with their perspective or their agenda. And it isn't just Greta that does it. We do it all the time. I do it. And so it can be, I guess the question there is, okay, hey, show the inconvenient angle as well. And when I say inconvenient, it's the one that doesn't exactly look so rosy for what you're trying to push. I think you actually gain a lot of credibility if you do. You might say, oh, let's talk about another way of seeing this data that might lead you to believe that my point isn't valid. And then you can say, here's why I still think the way I do, even though I'm seeing both sides of this coin.
Well, and that actually helps you make a stronger and more legitimate point, right? Or one that can be trusted in different ways, I think.
Yeah, I think so. I think it is. I mean, to me, it's just, I find it refreshing when someone says, hey, I'm going to show you something. And then, hey, you may be thinking this. And it's like, oh, yeah, I was thinking that. And then now you see what that says. And so it's like, okay, now what's this person's perspective on that? And now I'm much more likely to believe them and listen, actually. It's going to build a lot of trust because I don't feel like they're hiding something or hoping I don't think about something, right?
Well, and I think a good practice is anytime you're showing a graph, you're communicating with a graph, anticipate what's the first question that's going to come to people's minds when they see the information? What's the second question, right? And if you can anticipate what those are, or if you're unable, get a colleague or a friend, have them play devil's advocate or try to poke holes, because when you can also answer those, all right, or to your point, bring up the inconvenient pieces, it helps you both tell a more robust story, but then also, you don't get this feeling that you're cherry picking just to try to make the data play out in the way that you want it to.
Yeah, exactly. So you brought up the book Avoiding Data Pitfalls. What else is in there? I mean, it's interesting. The motivation behind that book for me was that I noticed that a lot of the debate, mostly on Twitter in the data visualization community, was about chart types, things like which chart did you choose, or is your y-axis at 0, etc. And it occurred to me at one point that your data could be flawed, or you might have made an incorrect calculation and you used a perfectly compliant, let's say, chart type, and everybody then would say there's nothing wrong with it, or they wouldn't question it, or they would think that as long as it's a bar chart that they can trust it. But really, there's so many opportunities from the point at which you start to collect the data or even pose the question in the first place, right? To the point where you're showing someone something, that there are steps all along that whole workflow where opportunities for errors pop up, right? So whether that's, well, you just didn't think of the nulls and you filtered them out, and then we even get to the design side of it, right? So maybe you chose some elements that were tacky or even maybe offensive to some people. Maybe that was on purpose. I don't know. But there are some ways we can dress up charts that actually take a great data set and a great chart and really kind of fumble the ball at the 1 yard line by not kind of putting it together in a way that people are going to find aesthetically pleasing or even just perhaps appropriate. So those are some of the other things we talk about in the data. Actually, I think a good example I just noticed on Carl Bergstrom's Twitter account from, I think, yesterday, actually. Carl Bergstrom, he's a co-author of Calling Bullshit, I think is the name of his book. He's a professor here at the University of Washington, not far from where I'm sitting right now. And Carl tweeted about data that showed vaccination rates by county, but it's so, when you look at it, you see the US, you see all these county shapes, but you can definitely see all the state shapes so clearly, right? And so he said, hey, that seems like there's something wrong. I mean, there's so many hard lines where all the state lines are. And so he supposes, and I think that he's got some potential backing in the tweet thread that he puts out there that says, really what's happening here is there's kind of an estimation happening by breaking down state level data and then trying to, I guess, let's say, what's the right word? It's state level survey data and then sort of doing some kind of an interpolation to the county level, right? So yeah, it makes you think when you look at it that it's measuring vaccination rates county by county by county and then comparing them all together. But really, that's not how the data was put together, perhaps, I think is his point. And so again, that's yeah, go ahead.
I was just going to say, that sounds like his data spidey sense was going off, right? If we bring this full circle to one of the ideas that we started with today, right? That if something seems like it may not be quite right, it gives you this uneasy feeling. And I think that's what we need to pay attention to when we're looking at graphs, because it's too easy when we see a graph to take it as fact and assume everything is perfect and look at it quickly and move on without giving it due course in terms of reading everything, understanding the sense that it is, sort of the feeling that it brings up, and yeah, all the stuff that goes along with that.
Yeah, I think you're right. It's what's your spidey sense, and to listen to it, to make sure it's tuned, to make sure it's active and live, because you're right. There's a certain, what they say, truthiness to charts. You see it,
yes,
and you're going to be likely to just believe it. And it's important to stop there and say, let's look at some of these details and ask what we're really seeing. Mm-hmm. Yeah, it's this sense of truth. Right. It may not be truthful, but it might be truthy.
So we've talked through a lot of examples of misleading graphs, and I think some tips when it comes to both being smart consumers of data visualizations and also things we should think about as we're creating graphs, right? The axes would be one of those things. So as a consumer, you want to make sure you know what you're looking at. So read titles, read labels. When you're graphing data, make sure you're plotting things consistently, or if you can't, you're making relationships and inconsistencies visually clear, right? And have good titles and labels so people know exactly what they're looking at. Work within people's conventions and expectations when you can, or again, if you're going against that, make it clear so that people aren't inadvertently making ill-informed conclusions. And this is a great place, as is a lot of the things that we've mentioned over the course of the hour, but to get a second set of eyes on your work. And it can be someone who's not familiar. It's actually helpful if it is someone who is not familiar, because of the sorts of questions that they will ask and the fresh lenses that they will bring that may help you, who has been talked about, you're looking at your graph for the 5th, the 6th, the 7th time, understand how someone looking at it for the first time might interpret things. And I think in general, just keep things simple, right? Straightforward, keep your wits about you, use some common sense, and above all else, use data for good and help others to do so as well. So with that, I encourage those who are tuning in to check out storytellingwithdata.com for many related resources. Ben, anything you'd like to highlight before we close it out?
Well, first of all, I don't think anybody captures the talking points as well as you do. So thank you for that amazingly concise summary. I think that's a great list. I also have as part of a handout that's in the Learning to See Data course on our site, there's a checklist that we put together called the 16 chart reading tips. It covers a lot of those things and others, but you can get that at bit.ly/chart tips. And that's free. You can see the list right there on the site, or you can sign up to the mailing list and get an interactive PDF version of it. You can send around and hand out for any time you're going to be going through an important chart and you want to make sure you take a look and cover all your bases. That's a handy starting point to use. So check that out at bit.ly/chart tips. So that's the only other thing I'll throw out there.
Awesome. Yeah. And we'll add that to the resources as well. And so for those listening, if you'd like to revisit anything we discussed here, you'll be able to do that at storytellingwithdata.com/podcast. And with that, I will say thanks for tuning in, and I wish everyone a fantastic day. Ben, good to chat with you as always.
Likewise, Cole. Thanks, everyone. Talk to you soon.